All right, so here we have that uranium-235 has a half-life of 704 million years. That means if you have a sample of uranium-235, this is an isotope of uranium, after 704 million years pass, half of it will have decayed. In another 704 million years, another half of the remaining will have decayed, and so on. All right? So first it says to write a modeling equation for the exponential decay of this. Okay, so for these problems, we're going to use the continuous equation. Okay, so what do we have here? We're going to use the equation y equals y naught e to the kt. Okay, so here's what we have. Y is the final amount. Y naught is the initial amount. So you suppose you start with an initial amount of y naught. The final amount after 704 million years have passed is half of the original amount. Okay? So here for y, we're going to put half y naught. Okay? Is equal to y naught e to the k times t. How much is t? 704 million. Okay, so the y naughts go away. So I have half equal to e to the 704k. All right. Now, I need to take an ln of both sides. So here I have ln of a half equal to ln and e make each other go away, and the 704k just becomes a regular number. Divide by 704. So k is ln of a half over 704. And that we put in your calculator, and we're going to get ln of a half divided by 704. Okay, it's a very, very tiny number, negative 9.845 times 10 to the negative 4. All right, so it's negative 9.846 times 10 to the negative 4. That's K. Now, the modeling equation, however, is going to be y equals y naught e to the value of K that you just found times t. Okay, so everything stays as a variable except for the K. Okay, next, part B. Part B says, how many grams of uranium-235 will remain after 2 million years if you start with 300 grams? So for part B, T is 2 million. Y naught is 300 grams, and you need to find Y. So Y equals Y naught is 300 e to the negative 9.846 times 10 to the negative 4 times T, which is 2. We're going to plug this into our calculator. All right, so let's go in here. Here's what we're going to do. So we're going to do 300 e to the power of, okay, I'm not going to put in that number again. So I'm just going to do answer, okay, control that negative symbol, answer times 2, okay? So to bring back the previous number. And here I get 299.41. 299.41. So after all that, okay, grams, after all that, only, 0.59 grams have disappeared. And that makes sense, right? Because it takes 704 million years for it to, for half of it to decay. Only after a measly 2 million years, basically nothing has happened. Okay, next. Use your model to estimate when 200 grams will remain if you start with 300 grams. So when will 200 grams remain? So now y is 200. Okay, so we're gonna plug it in here. So 200 is equal to 300 e to the negative 9.846 times 10 to the negative 4 t. Okay, divide by 300 on both sides. I get 2 over 3 is equal to e negative 9.846 times 10 to the negative 4 times t. Taking the ln of both sides, I get ln of 2/3 is equal to, these go away, negative 9.846 times 10 to the negative 4 times t. So t is ln of 2/3 over that crazy number. Okay, now let me show you how to do this here. So we have ln of 2/3 divided by, okay, now this is a crazy number, right? So I'm going to go here, okay, press up, go to that crazy number, press enter, and it will enter it into your equation. Isn't that cool? Enter, and that's 411.8 years, a million years. Okay, so roughly it's 411.8 million years. All right, thank you very much.